Okay, mitosis is fabulous. I know a lot of you are having some sort of traumatic stress issue. I say the word mitosis. It's fabulous. It is how all of our cells produce an exact replication. I find that kind of fascinating, that these cells are basically told by our body, hey, we need more, and they just get turned on and start replicating a perfect copy. And then when we have enough, the body goes, okay, you can turn off now. And they do, and they stop replicating. And they do all of this without us even thinking about it. Thank goodness. Could you imagine if you had to consciously think about replicating every single one of your cells? No. Hard no. Hard no. So we have some phases, and really, we're not going to go too terribly deep into the sea of mitosis. We're going to talk about the phases, what is happening in the cell during these phases. So our cells have a life cycle. Our cells are baby cells, teenage cells, adult cells, senior cells, and then dead cells. And it is during this life stage, this life cycle, this is what we refer to as interphase. Interphase is where the cell is not dividing. If you want just the most basic term, interphase, not dividing. It is growing and it is working and it's doing whatever little cell job it's meant to do. And he's living his little happy cell life. And he's just doing his happy little cell things. That's interphase. And the majority of the cell's life is spent in this non-replicating phase. That's all interphase means, not replicating. This is the period between my replications. So originally, we do have a little bit of change in our vernacular. Originally, this was called the resting phase. Resting meaning not dividing. But then they changed that because they were like, wait a minute, cells are never truly at rest. Right? They are still working and they're still doing energy-related things. Yes. They're still doing their little cell jobs. Oops. So they're never truly at rest. What interphase really means is simply not dividing. And so they changed the name of this interphase from the resting phase, which is incorrect, to what we call the metabolic phase. The metabolic phase, just your metabolism, is just you doing your bodily day-to-day stuff. And so interphase is also known as this metabolic phase, ipso facto, not dividing. We can see the nucleus while they are in this metabolic phase. And we have chromatin. What word does the word chromatin remind you of? Chromosomes. What chromatin is the blueprint. And this is just loosely kind of like spaghetti in a bowl. Just no rhyme or reason, just floating around the inside. It's not organized. It's not compiled. It's not compartmentalized. Just floating around the cell. And so this is all of the things that we can see during this interphase, metabolic phase, not dividing phase. Did everyone get that metabolic means not dividing? Okay, I said it like 47 times. I'll give you guys a minute. You guys are my note takers. Did everybody sign my paper? What you guys doing in midterm while everyone else is doing notes?
Muscles.
You're doing muscles. So did you go over your adjectives yet?
Yeah.
Like your Terry's and your Gracilis and your Latissimus?
Oh, no.
Not yet.
Yeah, we're on.
Oh, you just started. So you're just talking about like origin and insertion.
Yeah. Like we just finished.
You just, okay. Gotcha. The origin is the anchor, insertion is the movable end. Understood. There is some, if you want to go down a disgusting rabbit hole, yeah, pretty gross, pretty gross. So your bicep, so we're put together like puppets. We really are. Your bicep, the origin is here at your scapulohumeral joint. There's some skeletal system for you. Scapula-humerus. Your bicep is here, and this is the origin. The insertion is down here on my radius and ulna. And when this muscle contracts, it pulls like this. And that's what causes my arm to flex. Now, yes, we have very strong tendons that hold this muscle to the bone. Tendon is muscle to bone. You watch these bodybuilders, and they're doing their bicep curls, and they have a weight that is too heavy for them.
A power lifter.
Well, guess what? This is not an immovable force. The weight is the immovable force. And they will tear that bicep away from the bone because it is the less movable. It is the anchor, and they rip the anchor away. And so they'll be like, "Arr!" And all of a sudden, you'll see this pop, and their whole muscle just goes boink.
It's like there's a video of dude doing the incline, and you can just see.
Yeah. The whole pec just goes rip. Oh, it's awful.
Even more of a reason not to work out.
Guys, you have no idea.
There's my reason now.
It's so dangerous. Workouts are so, I tried, I told you guys I tried running and I knocked myself unconscious.
There's my cardio.
Ah,
How did you do this?
I ran and my feet went out from under me and I fell into the doorknob and knocked myself unconscious. And the sadder, sillier thing is I was demonstrating how fast I could run. It was a horror. I did. I knocked myself out right in front of the whole class. Dislocated my jaw.
Oh.
Yeah.
Speaking of which, did it pop back in yet?
It did. It popped back in that same day that I told you about it.
Okay.
Ish. It's still, I don't know if it's popped in correctly because I got a big divot right there in my face. Anyway, mitosis. One of the big important steps for mitosis is that we have an exact replication of the DNA. Remember, DNA is the blueprint. How is this cell supposed to function? What is its role within the body? How does it do its job? And so it's really important that any cells that are replicated have this exact same blueprint. And so one of the main steps, in fact, it takes several steps, is to replicate the DNA. Well, the first thing we have to do, so here's my interpretive DNA. The first thing I have to do is unravel it and have two separate strands. But I can make two exact copies of DNA because we know there are only two nucleotides that can bind with other two nucleotides. Apple tree, put your car in the garage. So even though I've only got half, I know exactly what pairs have to come. And so by splitting this DNA into two, I am now able to replicate two exact copies. This DNA replication is one of the things that starts happening during the end of interphase. We're not actively dividing the cell yet, because remember, interphase means not dividing. However, interphase, this is where we are going to start replicating, making a carbon copy of our DNA. So here we have our single DNA. We split this apart. We add the second nucleotide. We now have two strands of DNA. Then we go through mitosis, and we end up with two exact copies, two perfect cells. We call them the daughter and the mother. I don't know why. Why not the son and the father? I don't know. I don't know. The daughter and the mother cell.
My theory on that is men have two different chromosomes, women have the same chromosomes, so they're perfectly
split.
That's a great,
That's what I thought.
I didn't even think of that.
Yes, the XX versus the XY. Women
Right.
can give both X and Y, women can only give X. So
Sure,
if
that's
women
so
could
women,
reproduce together, they would only have daughters.
that is a really interesting idea. That's a very interesting theory as to why it's called a mother and a daughter cell.
Could you repeat that if you don't mind?
Oh, she's just saying why she thinks that it's a mother and daughter and not a father and son. Not testable, just interesting. I don't want to get confuse anyone because technically reproduction is meiosis.
Yeah.
But I get what you're saying as far as the XX versus XY.
Yeah.
Did you guys go into any genetics and behavior? Did you do like the square 4? Okay. Then,
So the DNA oh, I'm sorry, did I interrupt someone? But the DNA replication occurs during interphase, but not the like separation.
exactly, yes.
Okay, thank you.
What we would be seeing during interphase would end at this picture here, the middle picture. Because when we have this middle picture, now we are going into dividing. That's no longer interphase. That's where we're going into the mitosis phase. Mitosis meaning to divide and make two. That's a lot of words. Okay, don't, everybody put your pens down for just a second. Because what I don't want to have happen is you trying to write down every single word. I'm just going to take this and we're going to break it down. This one slide is the entire process of how do we split apart DNA and make a new strand of DNA. That's all it's referring to. We have these enzymes. So when we have our DNA, we need something to unhook those nucleotides because they're bonded together, right? Our adenine and our thymine, our cytosine and our guanine are bonded together. And we need something to come in and break the bonds. We have these things called a helicase. Helicase is what comes in and just buzzsaws down the middle of the DNA, breaking the bonds. Once we've done that, we have now two opposite strands of DNA. Right? When I say opposite, what I'm referring to is like if the first nucleotide here is adenine, that means that the first nucleotide on this side is thymine. And so we have one that goes this way from adenine up and one that goes this way. So that's what I mean by opposite. We kind of unzipped it. So what we then have, so the helicases pull them apart. The polymerases are going to come through and prevent them from rebonding. Because what DNA desperately does not want is to only have one strand. Because now he's super lonely and he's missing his BFF. And so what will end up happening is if we didn't have something that kept them apart, they would just rebond. We break it, whoop, they'd rebond. Kind of like two magnets. You break them apart, if you get them close enough, whoop, they just join right back together. So we have this, they move along, and they help to prevent these two strands from rejoining. Now we have two terms for these two strands. Lead and lagging. What the holy heck does this mean? So as I am, let me get a picture. I've actually got a picture here. I'm gonna go back, don't worry. Where's my, here I have a picture. I'm gonna get my laser pointer. So remember, as we are breaking apart, as we are unzipping this DNA, what is happening is you can see as we're unzipping, we're immediately reforming. We're immediately rezipping. the problem is the way that we re-zip. Here, as it's unzipping, I am laying it, so if we start here where it unzipped, it unzipped, I lay it down, so I'm here, I'll lay it down, lay it down, lay it down, lay it down. This is called the lead strand because it's a continuous reconstruction of the DNA. The problem here is that I have to go in this direction because of the way that I have to reassemble the DNA. So what that means is there's a stutter, otherwise known as a lag. So this, since I have to go in this direction, I'm gonna lay it down, lay it down, lay it down, and then I gotta skip back. Lay it down, lay it down, lay it down, and skip back. Lay it down, lay it down, lay it down, and skip back. And so it's this skipping back that I have to reassemble the DNA. That's why this one's called the lagging strand, and this one's called the leading strand. Continuous because I'm forming it in this direction towards where we're unzipping. This one is lagging because I have to reassemble in this direction and I have to keep skipping back. So now I'm reassemble, 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 but now I've unzipped and I have to skip back. Does that make sense to everybody? Did anybody fall off the bus with the difference between leading and lagging? And that's all we're talking about.
Yeah, I didn't get that.
Okay, so let me go ahead.
Yeah, isn't it just like assembling in the opposite direction?
It is. So let me. Oops, what am I doing? Why is this not letting me erase?
And this is the new strand that has the leading and the lagging strand?
Yeah. So here I have a DNA. And I've unzipped it to make two strands. Now what I need to do is I need to reassemble these two strands. This strand gets reassembled in this direction. This strand gets reassembled in this direction. So what that means is as I am unzipping, so now I've assembled, I'm assembling. As it continues to unzip, I just keep assembling. This one, however, because I have to assemble it in this direction, I assemble, it has to do with the sugar molecules.
Okay.
It has to do, there's a pentaform sugar. And so it's a one, there's a 1 point, you have to start at the 1 point, but because this is an opposite kind of a reflection, the 1 point is in the opposite position as the other point. So in this case, I'm doing assemble, 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 but now what do I need to do? Come back here to where it's unzipped. Assemble, assemble, assemble. Now I got to come back here to where it unzipped. Assemble, assemble, assemble. And I have to keep doing this little hop to get back to where the fresh unzipping has taken place. And this is where we have our helicase breaking this apart. And I have my other enzyme keeping them apart until I can reassemble the new form of DNA.
So the more you unzip, the longer it's gonna take a lag to.
Yes, that's exactly it. If I unzip a whole bunch, it's got to come all the way here. And then as it's reassembling, it's now unzipping a tremendous amount and it's now coming way back here and assembling. And that's why it does it in tiny chunks so that it doesn't get too far ahead of itself. And so we have the lag because it takes time to assemble. And then we have the little lag that it takes to jump over the part that we just reassembled and then reassemble. And then and that's why we call it the lag, because we have this little stutter this little hop stutter.
Mine's in a caterpillar.
Do what?
Mine's in a caterpillar.
Exactly. Yes. Like the inches and then goes inches and goes. Yes, absolutely. So now when we look at this picture, we can see here we have the two strands. The dark blue are my original strands. I have my helicase that have been breaking them apart. That's just an enzyme. It's an ungluing enzyme. This one is allowed to reform the light blue in this direction. So as I unzip, I just go in and lay down the new ones. It's a continuous reforming. Here though is my leg, and it can only be formed in this opposite direction. So I am form, 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 form. Uh-oh, now I got to skip back here. Form, form, form. Uh-oh, more has unzipped. Form, form, form. Uh-oh, more has unzipped. And that's where you get the stutter, the lag.
So does the lag take more energy than the lead?
It does. And we have, I mean, I'm going through the, like, barely scratch the surface in the detail of a leading versus a lagging strand. Obviously, this is not a genetics class. This is not, organic chemistry. We're just learning the concept of how do these strands of DNA get formed. So our lead is made continuously and our leg is made in little segments. And in fact, if I'm not mistaken, Douglas, go ahead and access that for me. I think they are referred to in, I might be making this up. You never know. But I believe, if I'm not mistaken, they're called Okazawa segments. That sounds true. That sounds true.
Make it work.
Make it work. Now, I'm pretty sure, I'm almost positive that the little segments that we have to go back are called Okazawa segments. Anyway, just trivia. I'm not going to test you on that. And so when we have finished, we then have our ligase, which comes through and rebonds the glue on the two new strands. And now we've got two brand new, shiny, exact DNA replicas. So we have the helicase that pulls it apart. We have our polymerase that keeps it apart. We then are forming our two new strands in two opposite directions. The leading strand is a continuous reforming. The lagging strand has to keep doing this little bounce back. We have our ligase, which re-glues the segments, and now huzzah, we have two exact DNA replications. What questions can I answer for you? So on my website, or not on my website, on my Moodle, there is the most adorable little video link that I have put called the Amoeba Sisters. Some of you know. They're adorable. Now, they're very elementary, but they're fabulous. The way they break this stuff down and they animate it, and it looks very, very, very clear. So I have linked the Amoeba Sisters as far as this, and I have a second video that I've also linked as far as an animation of DNA replication to try and get, I think the other one is a crash course. I'm assuming you guys have seen a crash course video. He's amazing. I have a huge crush on him. Huge crush.
I'm on TikTok.
Yeah, TikTok is good.
I don't do the TikTok. I don't even really know what that is.
Download it for him.
I have enough of the social media. I have exactly the amount of social media that I need in my life. And that would be none.
Like, TikTok is very rabbit hole-y.
I don't
the
need,
most rabbit hole-y of.
I don't, between Reddit and YouTube, I've got enough rabbit holes in my life. No, I don't need to do a TikTok. I don't want to do that one. I don't do the Gram, Insta, Snapchat, what is it, Instagram? And,
Instagram.
oh yeah, and those are two different things, aren't they? Yeah. I don't do any of that.
Instagram and the gram is the same thing.
I don't do any of that. No, hard no.
So just to clarify, the polymerases, they keep them from rebonding, but they also match new nucleotides, right?
Yes,
Okay.
absolutely. So they're the ones, if I pulled these two, so I've got my DNA, right? Okay, let's put our imagination caps on. So I've got my DNA, my helicase has pulled them apart and broken the bonds. Polymerase, because they're like, I want to get back with you. They're like these two lovers, you know, that are reaching for each other. This very dramatic movie moment. Polymerase is holding them apart and grabbing the nucleotides and attaching the nucleotides. Because once they get the new nucleotides, now they're satisfied. They don't try and reach for each other anymore. Then we have our ligase, which goes through and re-glues. And then huzzah, I have two brand new strands.
This is all during the interphase.
All during interphase. Because interphase, by definition, is not dividing. I can make new DNA and not divide the cell. I can replicate DNA, but that has nothing to do with the physical division of the cell. This is all preparatory. Because in order for me to get one cell into two cells, I first need a complete book of instructions. One of the other things that will happen is I'm going to need to replicate and duplicate all of my organelles. And so all of that is happening during interphase preparation. The cell is also getting bigger so that I will have the cell membrane to form two normal size cells. Preparation. Mitosis, all of this really fancy stuff happens before mitosis. Mitosis is just where we take this and go, that's it. That's all there is to mitosis with the noise. So all the fancy stuff happens during interphase. Now you can go through and you'll see I have multiple pictures that you can look at. I wasn't sure which photo would help which person. So I've got like 4 different photos demonstrating leading and lagging. So interphase itself is also subdivided. Now we're still not dividing, we're in preparation mode. We have the G1, the synthetic, and the G2. G meaning growth. During the growth 1 first part, this is where the cell gets bigger because I need to increase the surface area of my cell membrane in order to have 2 cells that are a normal size. If I didn't make my cell bigger, so here's my cell, and I want 2 cells this same size. But if I don't make my cell membrane bigger, look what happens. Did I end up with 2 cells the same size as the original? I did not. So I need to make that cell bigger so that I end up with 2 cells of the original size. That happens during, look what they named it, growth. Because guess what it's doing? Growing. Synthetic is where we are actively replicating my DNA. This is where my leading and my lagging and my helicase and my polymerase and all those words we just used, synthetic stage. And then finally in my growth 2, this is where we're packing a lunch. The cell has grown, huzzah. The DNA has replicated, huzzah. Now we are getting ready to actively divide, and that is hungry, thirsty work, I tell ya. And so what the cell does is it starts stocking up on a picnic. It gets proteins and enzymes. It starts stockpiling energy. Everything it's going to need to sustain itself through the increased energy consumption of dividing. So G1, we're growing. We're also creating our new organelle. Then synthetic, we're duplicating our DNA. And G2, packing a lunch, getting ready to divide. These are the three subsections of interphase. Is everybody okay? Am I going too fast, too slow? Is everyone like, oh my God, this is why I have PTSD about this topic? Everybody's okay so far? Fabulous. You guys are amazing. Amazing. What's the medical term for muscle? The myo. What would the medical term be if you have pain in your muscle? Myalgia. If you have pain from a muscle nerve, you have fibromyalgia, or sometimes we even refer to it as neurofibromyalgia. Look at that, you guys know medical terminology, that's amazing. All right, so what questions can I answer for you about interphase? Because we're about to leave interphase and enter the wild and wacky world of mitosis. Here we have Zoomer, did you have a question?
Confirm the lead and the lagging strands are part of the polymerases, right? Or is that different from a polymerase?
What the polymerase is doing is reassembling the appropriate nucleotides and holding the two strands apart.
So would the polymerase be made of that lead and lagging strand?
So when we go here, so let me get to a picture. So our helicase is what is breaking the bonds. Polymerase is what's coming through and attaching the appropriate nucleotides, holding them apart. So it's not.
The leading and lagging, it's just more. It's just an enzyme, not part of the DNA.
Yeah, it's just, thank you. It's just an enzyme. It does not actively become part of the DNA. When we're referring to the words helicase, polymerase, what was the last one? Ligand. Those are all preparatory. Those are what are actively allowing our DNA to split apart and then reassemble. They themselves are not technically part of the DNA. They're part of the process.
Okay, thank you.
So before we get ready to divide, what we've done is here we have my two exact copies. I have my two exact copies in this very familiar form. This is known as a chromosome. Now in this case, these chromosomes are super, super duper, super powered, super coiled. Super, super coiled. And they attach here, and this weak spot in the middle is where we're going to tug of war, pull it apart. So that one cell will get one, and one cell will get the other. But for right now, before we start dividing, they're just hanging out here in the nucleus. Because we haven't started dividing yet, we're not in mitosis. This cell is now super duper ready for mitosis though. So what are we gonna do? We're gonna pick this up tomorrow because time flies when we're having fun. Tomorrow we're gonna go through the 4 stages of mitosis. And we will be, all right, so I hate to do this, but we will be finishing up chapter 4 tomorrow. Tomorrow or Friday. I said we're gonna probably be finishing our chapter 4 because we just gotta go through the stages of mitosis. which is really pretty quick. We just discussed what has to be done in each stage. I think we're gonna plan to do a chapter 4 test Friday. We're gonna open it at 3 and it will close Saturday at 7. Your test yourself questions will be due Saturday at 7. And then when we finish, we'll be getting into our first true anatomical structure.
I need Sierra Smith's bags immediately. Where's
Okay.
her stuff? Oh, right there. All of this?
Yeah.
You okay?
Is this her computer?
Yes,
Yeah.
ma'am. Yes, ma'am, that's your computer.
Oh,
On the record.
okay, I thought you was.
Okay, so we will be finishing up mitosis. We will do review on Friday and finish up any little bit. And then I do have some review set for Friday. It will open Friday at 3 and close at 7 on Saturday. And your test yourself questions will be due on Saturday. And then we'll get started with our very first anatomical system, tissue. So comments, questions, concerns? Have a most wonderful day.
Yeah.